in science and multimedia. Some of you may know my work, though, in the form of a visualisation of ancient Australia called Sahul Time. This is the obligatory excavation photo to show that I have had at least a little bit of experience. Accompanying a friend of mine, Duncan Wright, up to Mobiag Island in the Torres Strait, and learning that that was part of the ancient land bridge between Australia and New Guinea really inspired me to sort of start developing this, which, cut a long story short, Sahul Time launched at CAAA in 2007, and really it was inspired by the idea of, could we take Google Earth and sort of extend the ideas that are inside it through an extra dimension in time. So, for example, it has an interactive, expressive timeline that can show all different types of things, animated layers that you can turn on and off, particularly ancient geography, which people like to see. There's ancient landscapes. So, for example, this is the Great Barrier Reef. At this point in time, so this is in the sort of close to the LGM, so it's a bunch of limestone pillars, but then the sea rises up and engulfs it, and we end up with the world as it is today. Normally I would give a demonstration, but I'm not sure quite how well those will work over this sort of medium at the moment. So I might try and press on for the moment, because I imagine a lot of people will have already seen this and tried it out themselves. There's even an interactive excavation for Devil's Lair, but I'm going to press on with this. Now, Sahul Time was built in Adobe Flash, which is a really versatile, expressive medium for authoring, which was really good for building a proof of concept, but made it really not very scalable, and made collaboration very difficult, because basically most of the data was sort of built into it in some ways. It would load some data, but didn't really use any sort of standard format. So that made it difficult. And if you've tried it out within the past about 6 months or so, you'll have had this notification that says that Chrome, and I think most browsers, are going to stop using Flash. Adobe has given up on it, and that is always the way that tends to happen with technology. So we have to try and make our data and our technologies future-proof if we can. So, knowing that that was the sort of thing that was on the way, and knowing that the project became a bit cumbersome, I sort of relaunched the project based on the ideas that had come out of it, and called it the Temporal Earth project, because Sahul Time really only means something to archaeologists, and this is a much wider project, really investigating all different types of temporal phenomena, history, archaeology, even geology, going back very far in the past, just to sort of investigate the phenomena and then build a delivery system that could handle a lot of content. So the sort of simulated geography, and to use KML datasets. KML is a format originally used by Google Earth, but importantly, it's been taken up as an open geospatial consortium standard, which means that systems now and into the future should attempt to support it in some way. That can vary how much. And also part of that is, the hope is, this is being my sort of personal project that goes around with me wherever I go and have collaborations, that it will be a basis for collaboration and sort of maybe even, I hope at some point in the future, maybe even to the point of crowdsourcing. Now, in the meantime, just to point out, Google Earth itself actually has a timeline, or had introduced one along the way, where, so for example, this shows the legacy imagery for Warsaw during 1945, at which point it had been pretty much obliterated. And the Royal Palace here in Warsaw, you can see that still this image, user contributed photo, is pretty much present day, 2006. So the Royal Palace, which had been destroyed completely, has been rebuilt perfectly as it was. KML, the original authoring language, has temporal capabilities. It's got quite a formalized way of incorporating time. These are the standard, you can see the standard geographical sort of spatial types. point line string polygon that most people would know from GIS. Ground overlay is where you put like a raster or a bitmap image. Screen overlay. And model actually is three-dimensional, this being a virtual globe. Like KML has been declared the OGC standard for data to go into virtual globes. Now, each of those spatial types you can associate with either a time stamp or a time span. They are the two main temporal primitives, time primitives that you can use. Time stamp is actually just a single date. I think I've got them the wrong way around here. Single date, and a time span is it comes into existence at one point, disappears at another time. Although, of course, the thing is that with archaeological data, we're often talking about much more complicated ideas about the dating of something. I'm reminded of the quote from War Boys saying that you end up having to put your round and fuzzy edged pegs into square holes when you try to adapt to a computer system. So the idea of having a more sort of research-specific software is the idea, perhaps, with this that will help out with that. Time in archaeology is always uncertain, but we have like quantifiable probability distributions. So my idea here is that maybe we could even think about a time primitive to add to these that would be an archaeological date, and I'll come back to that in a while. Just the sorts of things people do. This is like flu outbreak from years ago. Don't seem to be that many temporal data sets around, so I set to work creating some. So, for example, you can code a GPS track in KML, but why make it a GPS? Couldn't we have a historical GPS track of James Cook traveling around the world in 1770s? And so this is combining things together. That actually ended up as a museum exhibit at Canberra Museum and Gallery. And I tried to collect a really comprehensive data set of all of these little convict ships arriving. I've got just about every explorer, and this yellow area represents the spread of European settlement. So those things together actually perhaps map the temporality, certainly in very Eurocentric terms, but perhaps map the temporality of the point of initial contact between the indigenous inhabitants and newcomers. What you also see on here are the red lines are the telegraph lines joining up different areas, which really change the rate at which people communicate. And there's even images on here. These are icons representing photographs from a historical data set from the State Library of South Australia. So you can really use this as a way to plot like documentary materials through space and time. Okay, now one of the perhaps mistakes with this is that this is supposed to be representing 1859, but you can see, according to this, that the satellite imagery shows a lot of very European features. So one of the questions is, can we turn time back? Can we turn time backwards on these, like a satellite image? This is a satellite image of the southwest corner of Western Australia. You can see all this fairly bare area represents the disturbed vegetation. This is based on a vegetation data set from the Department of Environment and Heritage. They have one representing the extant vegetation today, and they also have one that they have put together representing the pre-European vegetation types. What I did was to take all the remnant vegetation types from this one, work out what colors they are in the satellite image, and then use those colors to fill in. So hopefully this is fairly close to a pre-European satellite image. This is taking it even a level further, which is to ask a question about climate. So I've always wanted not Sahul Time as it sits on the Monash server that it's on, doesn't really show anything about climate. So this is a way of deconstructing a satellite image and sort of trying to reconstruct it based on climate. And if you take that further and add in glaciers, and what I've done is particularly concentrate on Australia. So this is my most recent version of a reconstruction of ancient geography, much more detailed. So glaciers, you can see Western Tasmania, Kosciuszko is actually practically invisible, pretty small, and New Guinea. Drier climate, it's actually a bit exaggerated, and the ancient lakes, Lake Bass, so-called, and Lake Carpentaria. And I've actually recently discovered there's a bare earth color data set, which I'd rather like to use. Anyway, coming to something more important, which is the Victorian Archaeological Symposium in 2018, David Thomas was presenting on the radiocarbon dating visualization project, which I pricked up my ears. And so that's been funded as of last year. Beck, Caroline, and Jackie and David have been hard at work, basically verifying all the different dates, collecting all the extra dates, and calibrating them based on the new Southern Hemisphere calibration curve. So this is the distribution of dates that they have, also with respect to cultural areas. And I've actually done them as it happened. So I talked to David after this to talk about how to represent them, because he wanted to do an animation of them through time. At the end of it, he mentioned I had gone in there without really sort of slunk in the back without anyone particularly recognizing me. But it happened at the end of his talk that he mentioned that wanting to put them on Sahul Time. So I came up and mentioned to him that like I have a methodology that I've developed for how perhaps to treat radiocarbon dates. So this is the distribution of dates from the AustArc database by Mike Smith and Alan Williams and others. This is a previous version that's actually in an article on Internet Archaeology. So this is how someone else has approached like density curves as sort of changing colors, but that means you've sort of got to know the legend of colors and what they mean. And in fact, it's actually stopped working because it's all built in as a Java applet. This is my approach, which is to think of an archaeological date as a sort of lump of probability, a probability of 1 in its entirety, or maybe 95% if you're talking about the 95% confidence range. And if you think of that as being a bit of like paint that is dissolved in water, and then that water is diluted down. So in a sense, the probability gets in a less precise state, ends up sort of spreading out the probability across a distance. And so a logical way to represent that is to show it by using the opacity. You can see this first image, and the pair of pliers is behind the bottle, just so you can see whether it's whether the water is opaque or not. The first one you can see is almost entirely opaque and very dark blue. And as you get to the end, it's almost mostly transparent with only a much lighter blue. And this is really important because if you animate a set of dates and you just use the confidence ranges, then the worst dates, the least precise dates, actually end up dominating the animation because they last much longer than all the rest. So this is the way that I calculate the opacity of each icon. There's sort of a bit of a number here, which you see it's basically e to the negative 1,000, and that's sort of a number in years, which represents like a feature that you have to do. And this formula basically ends up producing, replicating essentially the absorbance that you were seeing, the chemical concept that you were seeing in those bottles. So to take one of the dates out of the data set we're working on, this one ANU 0693, so that's the range of dates, that's in sort of plus or minus CE, if that makes sense. So that's a range of 520 years. Put it into here, and you get an opacity of 85.2%. Then you have to convert that, for the sake of KML, to convert that to a hexadecimal number between 0 and 255. It comes out as D9. So that's what the KML color looks like. This is in alpha, blue, green, red. Don't ask me why it's in that order. So this is the code for the place mark. You can see the coordinates of the location. You can see those actual dates up in here. And then this here we have the color, and there's your D9 at the start, which happens to set the opacity. So this gives you a red color that is well, probably mostly opaque because it's a reasonably precise date. So what I'll do is I'll play this. This is the latest version of the animation. Okay, so try and make it so I can see my way to playing it. Okay, so coming back to the start. Actually, I can show it to you in Google Earth itself. So here we are. These are all the dates, and you can go through the timeline and basically explore them like this. And you can see some of them. I'll actually do I'll do the animation so that we can see what they're doing. But some of the ones early on are have a very wide range. They come up fairly vaguely, so quite transparent, but last for a long time. Then as we progress through time towards the Holocene, we get this sort of furious set of dots coming up, because those are dates that have a very narrow uncertainty range. So they end up being short-lived, but actually very opaque, so very clear. What I can do then is do an animation of just the Holocene, and to do that I have to adjust that number. So I think I take it, divide it by 5. In fact, the best way to demonstrate this is actually to use Sahul Time and my old visualization of the Austark dataset. It looks like this. I'm not sure how well this is going to come out, but I can find down in here this one, which is Mandu Rock Shelter. And so these are all the curves. Now these are just simple normal curves, and you can see that each one has, you can see along here, each one corresponds to an icon that's either very opaque and short-lived, or long-lived and less opaque and quite transparent. And when they overlay, they sort of do the equivalent of adding up the probability distribution. So you end up with an icon that represents the cumulative probability density at that point. I've even set up this. I did some basic calibration myself, so you can do this calibration curve. And one of the tricks is that if you decide you want to zoom in, so you zoom the timeline, then basically you should scale down all of these so that the more recent dates get to have an opacity that actually gives you an idea of their actual probability density. Okay, so that's just a vague overall thing of the sort of way we're approaching this. Just to say for a last thing, in terms of a replacement for Sahul Time, this is timemachine.earth with all the convict ships. But if you zoom out back to thousands of years, actually I think I turned it off earlier, but it actually has all of those new palaeogeographic reconstructions. They may take a minute or so to load, but that actually is going to be the replacement. This is under development in collaboration with University of Newcastle to try and turn this and make this available for archaeologists and the general public to use. All right, thanks very much.